Obtaining high-resolution, continuous video coverage of many moving assets is hard. Our paper presents a method that continuously updates the assets assigned to each drone. Assets are golden squares. The camera field of view for each drone is shown by a colored cone. The optimal solutions are shown with black circles. Unfortunately, drones have limited speed and cannot instantaneously reach the optimal positions. Our work compares the performance of algorithms that determine where the drone should move to ensure all assets are continuously tracked, while minimizing the area of the camera footprints. We can guarantee continuous coverage as long as each drone's vertical speed is larger than the fastest asset velocity divided by the tangent of half the drone's field of view angle. Our paper compares both centralized and decentralized approaches for assigning drones to assets. In these hardware demonstrations, volunteers steer the small forklift robots and move around cubes, while our algorithm automatically steers the 3 flying drones to minimize the sum of the footprint area of each drone camera. This metric minimizes the heights of the drones and maximizes the camera resolution. Our paper examines the effects of many parameters, including the number of neighbors used by the decentralized algorithm, how increasing or decreasing the number of assets and the number of drones changes the cost, and the effects of drone horizontal and vertical velocities. This top-down view shows the camera footprints of the drones and the moving assets. Our methods guarantee tracking of many moving assets using fewer drones than assets if the drone's vertical speed is a constant factor faster than the asset's motion, and the assets are clearly observable by the drone's sensors.